Alright, so this is question 4 from the practice exam. So number 4, what's going on here? Give me 1 second. Okay. Oh, that's what's going on. And what else is going on? Some stuff is going on. Anyway, so I have 4. Question 4, sorry, that was a late start. 4, we have, what is the chief product of the acid catalyzed hydration of 2,5-dimethyl 2-hexene. Alright, so we know that it's hydration, so we're adding a water molecule, and we're using acid as a catalyst. So here's what the molecule looks like. Right, this is 2,5-dimethyl 2-hexene. So the reaction, it's going to be with water, H2O, and the catalyst is acid, H3O, and I just put in 25 degrees Celsius. That's not part of the problem. You can actually ignore that, who cares? Alright, so I needed to do some background information. So what is, okay, so it says reaction of alkenes with dilute. Okay, so when we're doing an acid catalyzed hydration, you want the acid to be dilute. So dilute aqueous acid diluted with water, leads to Markovnikov addition of water. Right? So let's do that mechanism. So here's the example that they give us. Let's see. We have this alkene right here. This is step 1. Sorry, that's a little crowded. We have that alkene plus water, and this acid. Actually, probably the acid should have been on top here, and the water should have been on the bottom to show that this acid is aqueous. Okay, this is aqueous acid. It's diluted. It's diluted in this water. Alright, so what happens when... Okay, sorry, don't pay attention to that. So we take this molecule and we put it in aqueous acid. So it reacts. It's a slow reaction, going back and forth. And so the bond, this bond, the pi bond from the molecule, gives both of its electrons to one of the hydrogens of the acid, and then that gives its electrons to the oxygen of the acid. And so we get Markovnikov addition, right? We look at this molecule. This C has no H's. This C has 2 H's. So, of course, the H that we just picked up is going to go here. And so we get CH3, which we had before. And now we have a CH3 because the hydrogen went here, and we get a carbocation. It did that so that the carbocation would be 3rd degree, so that it would be the most stable, plus water, right? So the water came from when you deprotonated this acid and this hydrogen went to this molecule, you just had H2O, which is water, and it was in water anyway, so that's where the water came from. So step 2, which I think is an SN2 reaction, but that's not what we're talking about right now. So step 2 is getting, okay, so we have the carbocation from step 1, right? And then we have the water. This carbocation, the water is going to act like a nucleophile, giving its 2 electrons to the carbocation. And that's a fast reaction. And what we're going to get is because, okay, so the 2H, it's an H2O. So when it attaches itself, now oxygen is bonded to 3 molecules, carbon, hydrogen, and it has 2 electrons. So when you do like Lewis dot, which I'm not going to do here, it becomes positive. It's positive. So then step 3 is is deprotonation, right? This is how you turn it into an alcohol. Actually, okay, so deprotonation. Now, there's something I should have mentioned right at the beginning. Give me 1 second. I want to see. Alright, okay, so this is, okay. This whole mechanism that we're dealing with right here is called addition of water to alkenes, acid catalyzed hydration, right? So everything, addition of H2O, no, whatever, let's just stay on track. So step 3 is deprotonation. I hope I didn't, like, you remember this, So we have deprotonation. So here's the molecule we made. And it had 2 hydrogens on it, and it's positive. And then remember, there's a lot of water. This whole reaction is being done in water, so there's water. So the water comes and it takes a proton, it deprotonates. That proton gives its electrons to the oxygen, and we get our final molecule, which is CH3, CH. Our final molecule, which is, okay, it's like CH3, the CH3, 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 the C, and the OH, right? It's a terbutyl alcohol, plus H3O, the acid, when this oxygen took this hydrogen and added it to itself, it became H3O, which is an acid, and it's positive. So now that we know that, we can answer the problem. So it was 2,5-dimethyl 2-hexene. So this is step 1, right? This is the addition, the breaking of the alkene. So let's just draw our molecule. I put the hydrogen here so I know where this carbon has 1 hydrogen, this has none, so of course it's marked carbon addition. So we know where the hydrogen's gonna, this hydrogen's gonna go. So it's okay, again, it's acid diluted in H2O. I should have put the acid on top because that makes more sense. But so it's acid diluted in H2O. This pi bond acts like a nucleophile, gives both electrons to the hydrogen of the acid. That bond breaks, it gives its 2 electrons to the oxygen. And this is a slow step. And the product that we get is this. The hydrogen that we just plucked off goes to the carbon that had the more hydrogens to begin with, and the carbocation is here. It's a tertiary carbocation. There's not going to be any methanide or hydride shift because this is already tertiary carbon carbocation. You can't get any better than that. Plus H2O. The H2O came from the deprotonation of this acid. H3O removed protein, becomes H2O, and it was an H2O to begin with. Step 2, right, we got, so here's our molecule with the H's and the H's, right? Now this is when the water comes in. And it's going to attack the carbocation, right? Now, it can attack, this is trigonal planar. It's flat, so it can attack from A, and it can attack from B, top or bottom. So we look, is this going to form enantiomers, or is it going to form one product? And it's going to form one because I look, this carbon is attached to methyl. You need 4 different kinds of groups attached to the carbon, and since I already have 2 that are the same, that's not going to happen, so there's only going to be 1 molecule. So I have the fast step, and that gives me, right, I have the methyl, and then the water attaches, and it's positive because it's H3O, right? And then step 3 is deprotonation. So here we have the molecule. Hello. Oh, my microphone's doing that weird thing. Alright. I'm gonna have to finish this. I gotta stop because my microphone's gonna be making this weird noise if I don't. I'll finish this in the next video.